Aging and Longevity Risk Analysis, using both the VMT Energy Model and Topological Data Analysis, number 1380, VMT Sharp 720, TDA Sharp 004, October 6, 2025. Gerald C. EclaireMD Foundation. Category: Aging Longevity, Computational Medicine, and Systems Health. Mission statement: I write these medical papers not for fame or recognition, since I have already lived a long and successful life, though not always a healthy one. My purpose now is to share what I have learned about health, disease, and medicine, so that others can better understand their own conditions, prevent illness, and live longer, healthier lives. Preface: In 2010, I began measuring my health age and biological aging trajectory. The difference between my real age and calculated health age became a new strain indicator within my viscoplastic framework. During these 16 years, I carefully recorded thousands of daily observations on diet quality, walking steps, and combined sleep and stress, S&S. These data now serve as a complete longitudinal dataset for applying both physics-based viscoplastic medicine theory, VMT, and mathematics-based topological data analysis, TDA. The objective is to explore whether the aging process, when stabilized through lifestyle disciplines, diet, exercise, sleep and stress, shows the same kind of geometric contraction and viscoplastic energy flattening already observed in my cancer and stroke studies. Introduction: This study applies both VMT and TDA to my 16-year, from 2010 to 2025, health aging dataset. The output strain is the age difference, health age minus real age. The three input stresses are diet, steps, and sleep and stress scores, S&S. The goal is to investigate how biological aging transitions from a chaotic, unstable phase to a stabilized healthy phase. VMT energy analysis results, from 2010 to 2025. The viscoplastic model measures the total energy accumulation caused by these three stresses, acting on the body's aging structure. Major findings are summarized below. Total energy behavior: the cumulative viscoplastic energy rose steeply from 2010 through 2014, reaching 84% of total energy, and flattened thereafter through 2025. This indicates that by mid-decade, the irreversible deformation energy of aging had been mostly accumulated and later stabilized. VMT energy contribution ratios: diet is 41%, steps is 40%, S&S is 19%. Pathophysiological interpretation: during from 2010 to 2014, biological stress energy accumulated rapidly, corresponding to visible pathophysiological decline and high aging strain. After 2015, the energy curve flattened, demonstrating internal stabilization of metabolic and vascular systems through consistent and stringent lifestyle management. Topological data analysis, TDA, results. To verify the VMT findings mathematically, I then applied topological data analysis to the same normalized dataset. The TDA framework reveals the geometric shape and evolution of health over time. Step 1. Data construction: a four-dimensional point cloud was created using three stressors: diet, steps, S&S, and the strain of age diff. Step 2. Distance geometry. Pairwise Euclidean distances showed two clear geometric regimes. Regime A, from 2010 to 2014, high dispersion, irregular structure, unstable phase. Regime B, from 2015 to 2025, tight clustering, stable topology, healthy equilibrium. Step 3. Connectivity and shape: the persistence diagram indicated a single connected component after 2015. H0 is 1, H1 is 0, showing no recurring loops and confirming an irreversible one-way transition. Step 4. Feature correlations, geometric gradients: diet is 0.91, steps is 0.93, S and S is 0.86. These values nearly duplicate the three VMT energy contribution ratios: diet 41%, steps 40%, S and S 19%, confirming that both physical energy and mathematical geometry point to the similar behavioral hierarchy. Step 5. Cluster dynamics: average TDA cluster spread contracted from 0.83, from 2010 to 2014, to 0.37. From 2015 to 2025, a 56% reduction, 37% versus 83%, similar to VMT energy reduction. This contraction represents the geometric analog of the cumulative VMT energy flattening after reaching T84% in 2015 and 100% in 2025, with a reduction of 81%, 16% versus 84%. Comparative interpretation: TDA versus VMT. Theoretical basis: VMT models energy dissipation and irreversible strain. TDA reveals the structural geometry and connectivity of multidimensional data structure. Data used: identical normalized variables, diet, steps, S&S, and age diff over 16 years. Key findings: VMT shows energy stabilization after 2015. TDA confirms shape stabilization after 2015. Dominant drivers: both methods identify diet and steps as nearly equal dominant stressors, with S and S as a secondary but essential stabilizer. System dynamics: VMT shows irreversible energy dissipation. TDA shows irreversible geometric contraction, with no recurrence of chaotic loops. Time frame: both indicate from 2015 to 2025, as the stable equilibrium phase corresponding to improved systemic health. Combined insight: both frameworks converge on the same conclusion. The early years, from 2010 to 2014, represent a chaotic phase with large fluctuations in aging strain and metabolic stresses. The middle years, from 2014 to 2016, form a transitional corridor. The later years, from 2016 to 2025, demonstrate a compact, stable, and irreversible physiological state. VMT quantifies this through energy. Flattening TDA visualizes it through cluster contraction and a stabilized geometry. Together, they show that disciplined control of diet, physical activity, and sleep with stress management not only lowers measurable health age, or quantifiable age difference, but also reorganizes the shape and structure of the underlying biological system. Conclusions: physical and mathematical convergence. TDA validates VMT by confirming that aging stabilization manifests both as physical energy dissipation and as geometric contraction of health topology. Pathophysiological or biomedical significance. This study provides evidence that strict and sustained lifestyle control can reverse chaotic biological aging and maintain long-term systemic equilibrium. Broader implication: the integration of VMT and TDA demonstrates how the combination of physics and mathematics can provide a more complete picture of human aging, quantifying not only how much energy is dissipated but also how health structure reshapes itself into stability. Figures, for reference: 1. VMT stress-strain energy diagram. From 2010 to 2025, the cumulative aging energy curve flattens after 2015. The smaller strain stress loops after 2016 indicate a stabilized and healthy state in the aging process. 2. 3D scatter diagram, TDA space, diet steps S and S space colored by age diff, showing a contraction pattern from scattered red points, from 2010 to 2014, to a compact blue cluster, from 2015 to 2025, representing improved stability and health consistency. Appendix A, TDA data table. TDA data table, strain versus 3 normalized stresses, from 2010 to 2025. Year age diff diet and steps in SSN datast regime. Correlation with strain, age diff. Diet N is 0.91 steps and is 0.93 SSN is 0.86. Average TDA distance, cluster spread. Regime A, from 2010 to 2014. 0.83 Regime B, from 2015 to 2025. 0.37 total contraction, 55%. Interpretation summary. From 2010 to 2014, chaotic topology, unstable aging strain. From 2015 to 2025, compact manifold, stabilized healthy phase. The topological contraction from 0.83 to 0.37 confirms the same pathophysiological stabilization, shown in the VMT cumulative energy from 84% to 100%. Disclaimer: this content is provided for educational reference only, and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article and related materials belong to the author, Gerald C.